Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look how to apply simple transformations to sine and cosine graphs. So it turns out for y equals sine x and y equals cos x, they follow these same rules that we learned for polynomials. So the graph of f of x plus k is the same as the graph of fx, but the k just shifts it up or down by k units. And similarly, if we replace x by x plus h, that shifts the graph left and right. Remember, for this second one, it sort of goes in the opposite way that you would expect. H is positive, it goes to the left. H is negative, it goes to the right. So let's look at this as we graph something like y equals sine of x plus 3. So what that will do is take the sine graph and shift it up by 3. So when you're taking cos or sine and you're shifting it up or down, this number by itself you can sort of see as the middle of the graph. So the graph's middle, like its mean position, is going to be along this line here. Now we know that for y equals sine x, it lives between 1 and minus 1. Its maximum value is 1, its minimum value is minus 1. So shifting it up by 3, this graph is going to be between 4 and 2. So it's sort of like the same graph as y equals sine x, but you view this line here as the origin. So remember, for y equals sine x, it starts at 0. So y equals sine x plus 3 will start here at 3. So then at 90 degrees, it reaches its maximum. It goes up, then it comes down to where it started at 180. 270, it reaches its minimum, and then it goes back up. So this is what the graph will look like. Remember, it doesn't stop just between 0 and 360. It keeps going along like this. It'll keep going and going and going. And that happens in both directions as well. So this here is the graph of y equals sine x plus 3. As I said, it's exactly the same as the graph of y equals sine x, but just shifted up by 3. So instead of this being the middle position, going from minus 1 to 1, 3 is now the middle position, and it lives between 2 and 4. All right, now we'll just do an example of the other type of transformation using cos, so please pause and copy this down if you need. So now, let's graph y equals cos of x minus 90 degrees. So firstly, I'm just going to quickly draw the graph of y equals cos x so we can see better what's happening. So I've graphed in green y equals cos x. So y equals cos of x minus 90, it will be the same graph except shifted across by 90 degrees. Now remember, if this is minus, it sort of goes in the opposite way that you'd expect. This will actually shift it this way, 90 to the right. So what that means is, see, we know that cos reaches its maximum here at 0, so we can move that point across to here, across by 90 degrees. So we can move this point here across by 90 degrees, and so on. We're just moving every point across by 90 degrees. And after we do that, we just join them up. So in blue, we have the graph of y equals x of minus 90 degrees. So when we use this second type here, what we've done here, we call this a phase shift. So the blue graph is a phase shift of the green, 90 degrees to the right. So hopefully you realize that the blue graph is actually the same as the graph of y equals sine x. In fact, this graph and this graph give you the exact same graph. The reason we call it a phase shift is all we've done is we've just shifted everything, every phase across by 90 degrees. And that was the difference when we looked at y equals sine x and y equals cos x. They were the same graph, except the sine graph was shifted across by 90 degrees. So that's why these two give you the same graph. So these rules that apply to polynomials also apply to trigonometric graphs. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.